So we're a family of organizations that's really sitting underneath the Okavango Wilderness Project. As you can see on the top right there, we have Wildbird Trust, which is essentially South African, and we have Wildbird Trust Botswana. We have Fundação de Cima, which is essentially the Angolan branch, and also working towards Namibian Wildbird Trust. But as this photo shows, and this is actually in Tempwe, this was taken last year, there is, there's, as these rivers are transboundary, so are our staff. So really a collaborative effort, a lot of good harmony between staff and researchers and logistics and whoever else is contributing towards this common goal and this family of organizations that's working towards protecting the headwaters of the Okavango Basin, all the way down to beyond the Okavango Delta in the Mahari Pans. So just in this photograph on the left-hand side is Curlin Costa. He's actually in Tempwe right now, so he is there. And some of the structures that are still there in Tempwe are from during the Angolan Civil War, 1975 to 2022. And really that just speaks to how challenging it is to get up into these headwater regions. You can see there's a team which has got a diverse range of nationalities here. And this is just a small portion of the family of organizations and the people that are actually working on the ground from what this photograph is taken. So just a little snippet of the amount of people that are working towards this. Okay, so what we do, really the first sort of bullet point there is around the science. And working towards protecting these headwater regions for the Okavango Basin. And really, it's about conducting research. Most of our research is really about river baselines and going down rivers and collecting data, observation data. And then trying to connect that observation data with local indigenous knowledge. And that's really where the storytelling comes into play. So that's the real asset of having a partner like National Geographic, because they really excel in the storytelling aspect when it comes to education and for example all the documentaries that have been produced along this river basin in Kashi that Stephanie mentioned earlier, into the Okavango, which was the mega transect that took place in 2016 from source to sand, right from the Krita source lake all the way down to the end of the Mahari Pans. And then really just extending that towards sustainable livelihoods and community-led work, where a lot of the work is tailored towards what communities are already doing in protecting the landscape, and also providing tools and expertise for them so that they can turn their conservation efforts into something meaningful for them, for their local economies. So going back to the theme of this presentation, Africa's water towers beyond snow and ice. Why study water towers is the question here. Really what we're talking about here is a high altitude area that's a very important source water region and sustains flows downstream throughout the year. The map that you see behind the question why study water towers was produced for the ESRI user conference. So as I was introduced, my background is in geospatial science and GIS and remote sensing. So ESRI, so ESRI is the technology company, almost like the Google of mapping. And so we produced this map along with cartographers at National Geographic. Some of those team members are here watching today, so I really appreciate their attendance. This Angolan Highlands Water Tower map. And you can see that in that sort of behind that green title is this gray boundary for the Angolan Highlands Water Tower. And you can see that this water tower doesn't just support these two very important basins or these two very important rivers, the Kwito and the Kubangu, that flow into the Okavango Delta, but many others. To the northeast, we have the Kasai River Basin, which is part of the Congo River Basin, which is the largest river basin in Africa. We have the Upper Zambezi, the Kwanda, which are both supporting the Zambezi Basin, which flows into the other ocean that you can't see here, the Indian Ocean, out in Mozambique. You have several other basins that flow into Namibia, the Kunene and the Kuvalai. Here it's labeled Etosha Basin. And then some rivers that are more closer to home for Angolans would be the Kwanza River Basin, which really feeds the Kwanza River, which is the major river of Angola because of the amount of people that rely on it in Luanda, which majority of the population of Angolans live. So it's not just about the importance of the Okavango Delta and the National Geographic Okavango Wilderness Project, but all the other basins that this water tower contributes towards. And we can easily talk about the biodiversity in the Okavango Delta. We can wax lyrical about all the biodiversity and important biodiversity that's downstream of this important source water area. But in fact, the Angolan Highlands Water Tower is a center of endemism on its own. So the team has worked towards, many naturalists have worked towards this, biologists have worked towards this center of endemism, and incredibly, there's a wealth of biodiversity there. So since 2015, the various naturalists and biologists that have been up into the water tower have discovered 143 new species, which are currently being described and new to science. An important area for endemism in Angola, meaning that those animals are only found there. Across all taxa, so including some fishes, bats, mice, flowers, lizards, snakes, even fungi. So very interesting biodiversity, including Africa's smallest dragonfly, the Lilliput prickleg, a new tarantula species that's the size of a human hand, and it's actually got a horn on its back. And someone that I will talk about quite fondly is Dr. Steve Boys. Actually had a small fish named after him called the Microtenopoma Steve Boise. And I think that that's just a homage to how much work that Steve has done in the basin and bringing these organizations together. So very, very important area for endemism, not just where in terms of the Okavango Delta, but at this headwater area too. So talking about our recent paper, I published this paper with my supervisor for my PhD, Professor Stefan Woodbourne. So in the title, we define the Angolan Highlands Water Tower. Luckily for us, there's been a lot written about the Okavango Delta. So in this instance, we had the opportunity to look upstream at where this water comes from. Really, scientists are interested in the Okavango Delta because of the level of biodiversity and this annual flood that comes through the delta itself. And it's really a delta. It's a major alluvial fan, essentially in a desert. And without this headwater area, it would simply dry up. And we looked at a 40+ year precipitation budget for the headwater catchments of the Okavango Delta. Within this slide, you can actually use the QR code to gain access to the paper. It's been accessed thousands of times and has had several mentions in conservation media. So very important output that was published in June 2023 in environmental monitoring and assessment. And it was published just before the ESRI conference, so we could present a lot more comfortably and confidently during ESRI. So within the local context, the source of life, or the Lisima ya Mono, it's meaning the source of life in the local Luchazi language. And as I mentioned earlier, we're talking about very important areas of biodiversity in terms of the Okavango Basin, which this source water or headwater or water tower region contributes towards. 2/3 of Africa's remaining elephants, that's essentially in the Kaza Basin and in the Kaza region. Keystone populations for giraffe, leopard, cheetah, and more. And then also speaking towards people, food security, water security. And this is really just in the context of the Okavango Basin, and these numbers will go way higher, and the influence is way higher when you put into context the Congo Basin, the Zambezi, and so on, and all the different countries that this water tower contributes towards in terms of fresh water. So we're going to just unpack a little bit more about this term, a water tower, or what is a natural water tower. And it sometimes depends on who you ask. If you ask maybe a geologist, they would talk about a source water region, and they'll talk a lot about aquifers in this case. And really the term water tower has been used by within academic literature. It's quite a relatively new concept that people are getting used to, but it's been very nicely described by Imbecile et al. And Imbecile et al., I'm referring to a paper that was written in 2020, and that study was also in contribution with National Geographic, so in connection with National Geographic, where they produced the Water Tower Index for the world. So as far as Imbecile et al. Are concerned, it's used to describe an area with large quantities of water, which are stored in mountain ranges. So just as you would imagine a reservoir storing water in a high up place, that water can flow downstream and feeding people and nature and livelihoods. So what's very important about a water tower in this context is that compared to its downstream area, the water tower region receives a greater amount of precipitation and has higher runoff, and delays its release to the downstream areas because of certain mechanisms, either be it snow or glaciers or lake reserves. So there is some sort of storage that's allowing this water to flow down, and we have this supply and demand being met quite well. So Imbecile et al. Talk about a buffering capacity. So there's this buffering that comes into play when you're talking about rivers. You might have a dry season or extreme heat season or hot season, and maybe that river will not flow during that period. But what water towers do, because of their buffering capacity, because of the mechanisms they have, let's say, for example, snow and ice or glaciers, during that period, those mechanisms will sustain flow throughout the year. So really, the buffering capacity and the seasonality of flow it's constantly being met. As the demand increases, the supply is there. It's a very important concept for these natural water towers. And we're going to just continue a little bit with this paper from Imbecile et al. It's very important in the context of this whole concept of beyond snow and ice. So within their definition, they considered cryospheric water tower units. And what they did was they imposed thresholds. So they used snow-derived data, and they used glacier inventories because of that buffering role of water towers. And it was used as a defining features of water towers. So, and they go on to say that consequently, there's areas in Africa, for example, that don't have much permanent snow and ice reserves, and they don't meet the criteria of the water tower unit. So they're left off of the global map. So it says in this title of this slide. And what you see in the very first figure that they present is the water towers index of the world, including the world's water towers. Unfortunately for Africa and for Australia, the two driest continents, they do not have any water towers, simply because they use the snow cover and this glacier inventory within their defining criteria. So for me, it's not to say that I'm very critical of this paper. You can see this paper was published in Nature. It has over 800 citations, 44,000 accesses. So a lot of good work has gone into that paper. But it, as an African scientist, provides a very enticing opportunity to go and understand what's happening in Africa and how can we start to define our own water towers. So moving on, there has been some literature, and in this case, a report written about Africa's water towers. And this is coming out of the United Nations Environmental Programme, or UNEP, in 2010 Africa Water Atlas. And in this water atlas, a very important map was displayed, which is there on the right-hand side, which includes Africa's water towers. And what I've done just to help with the naming of the water towers is I've simply just ranked them in terms of size. So I digitized the map, which I find it's a very important map, and I ranked them in terms of size. So as you would see, we have the Ethiopian Highlands, Angolan Plateau, and Lesotho Highlands as the biggest. The Ethiopian Highlands contributes to the Nile Basin, and for our audience here, a lot of them are coming and representing and talking about the Nile a lot in their work, and through their media outlets. So 11 different countries are part of the Nile Basin, a very important river, the longest river in Africa, not just for contemporary times, but also historical times, and cultural significance of the Nile is incredibly big. And the Nile doesn't just have one water tower, it has three, according to this map. It's the Kenyan Highlands, the Albertine Rift, and then the Ethiopian Highlands, as I've mentioned. And then focusing again on those top three, and one that's more closer to home here, I'm in Johannesburg now, so we can just go back. The Angolan Plateau, it's matches quite similarly to the Angolan Highlands water tower polygon, so we're fairly confident that we're not overestimating the importance of the Angolan Highlands water tower. And it's a very important water tower because, and I will get onto this and explaining this further, but it's a very important example because you have an area that has a high rainfall and an area that is requiring that water in terms of the Okavango Delta, which is essentially a desert. So without that connection, the Okavango Delta would simply dry up because of the latitude that it's at and the amount of heat that is experienced there. And then closer to home for us here in South Africa, the Lesotho Highlands are incredibly important, especially for the eastern part of South Africa. Essentially, Lesotho supports Africa's human water demands. And I just want to say one more thing about this map, which it's a very important map, but it is quite important for the purpose of this talk. When it comes to this map, only 2 sentences were said, and myself and other colleagues have tried to track down the authors of this map and whoever presented this map, because we'd like to understand a little bit more about how they got to these polygons, and some of them are quite obvious, but some of them are a little bit more tricky. So what they did in defining these water towers, they were identified by relative elevation, so generally 200 to 800 meters above the surrounding area, and precipitation above 750 millimeters per year, and runoff above 250 millimeters per year. So quite broad defining criteria. And then I think the second sentence, and this is the only 2 sentences that they say about this very important map, is they were also selected for the contributions they make to water resources for populations beyond their delineated boundaries. So a very important concept there is that, for example, in the Angolan Plateau or the Angolan Highlands water tower, there might not be a lot of people living there, but this source water region is important for all the areas that are beyond its delineated boundaries. So there's areas for populations or populations that are really far away from the source water region that depend on that source water region. I think it's a very important consideration when we want to define water towers. So redefining the water towers this is a little bit of a summary of what we've just spoken about. Again, the Immersiel paper, we really spoke about the defining criteria was about snow and ice, and what it meant was that Africa was left off of the map. And then in the 2010 definition, we only had those 2 sentences, and it really doesn't account for the diverse range of freshwater ecosystems across the continent. So it leaves out, for example, several of Africa's important water towers, for example, in Zimbabwe, in Cameroon, in Ghana, in Togo, and Central African Republic, and other highlands in Rwanda, Burundi, and the DRC. So yes, it does a very good job at depicting major river basins that we've spoken about, the Congo and the Nile and the Zambezi and so on. But there are others that are left out, and we'd like to unpack that a little bit further. So just to pause here, Stephanie now is going to play the Angolan Highlands Water Tower explanation video. This video was produced by National Geographic by the cartography team in connection with our paper, and it was presented at ESRI last year in San Diego. I just want to see, is it audible? I don't hear it currently. Let's just hear.
In Africa's arid regions, highland
it's
water...
audible. We can restart it. Thank you, Steph. Okay, it's not audible again for me. Something happened. Right, let's just try and get that. I promise you'll love to see this video. It's really like my pride and joy. Try and get that back up.
I need to click the share sound. Now we should be in business.
Can we just restart it? Yeah, great.
In Africa's arid regions, highland water towers play an important role in storing and providing fresh water which sustains life downstream. The Okavango Delta, a UNESCO World Heritage Site in Botswana, lies in the semi-arid Kalahari Desert, but its source is hundreds of kilometers away in the Angolan highlands. Angola's landscape is dominated by the highlands of the BA Plateau. Its rainy season lasts from September to April, with its heaviest rainfall in the north and on the cooler central plateau. The highlands supply water to 11 river subbasins, 8 of them transboundary, including source waters of the Congo and the Zambezi, and the key tributaries of the Okavango, the Quito and Kubangu rivers. These highlands are an important regional water tower despite the absence of snow cover. The area lacked a defined boundary, which hindered conservation efforts. For that reason, the National Geographic Okavango Wilderness Project identified the Angolan Highlands Water Tower as an area of the BA Plateau above 1,274 meters. Annually, this water tower supplies an average of 423 cubic kilometers of water. However, the contribution to each subbasin varies. Okavango's catchment is shared by Angola, Namibia, and Botswana. It's estimated that over 95% of the water that flows into the Okavango Delta via the Quito and Kubangu rivers falls as rain in the Angolan highlands. This crucial rainfall accumulates in source lakes and extensive peatlands in a highland region known locally as Lizima Lia Mowono, meaning the source of life. In spite of their overlapping rainy seasons and adjacent headwaters, the water reaches the delta from these two rivers at different rates. The longer Kubangu runs a steeper, faster path over compacted soils and feeds the first Okavango flood pulse between January and March. Meanwhile, the meandering Quito seeps through extensive spongy peatlands and feeds the second surge in April and May, then sustains the delta through the dry season. The extent of flooding in the Okavango appears strongly correlated to the amount of early rainfall. The water tower's wettest year on record, 2011, led to the largest known inundation, while the 2019 drought produced the smallest recorded flood area. Defining the Angolan Highlands Water Tower and quantifying its contributions to rivers downstream will help with the conservation of this critical freshwater resource.
Awesome, wonderful. I'm just aware of time, so we'll go through this. So yes, just some key findings from this paper, and I don't want to repeat too much, just that it was the first to find the boundary of the Angolan Highlands Water Tower. The 423 cubic kilometers of water that fall as rain, it's often being compared to swimming pools, 170 million Olympic-sized swimming pools, that's per year. The amount of countries that it supports, 7 different countries, not just Angola, and that's really in respect to the collaborative effort that's going on between all these countries, specifically Angola, Namibia, and Botswana. And then in terms of the Okavango Delta, 95% of the water, it's estimated that 95% of the water is provided by the highlands themselves. And then just a couple more points on that. It was mentioned that there's a lack of ice, and we know that Angola doesn't have snow and ice reserves. And we'll talk through the mechanisms that are allowing this water to flow all year round. And really, it's about peatlands. This is what I studied during my PhD. We've estimated peatlands to 1,634 square kilometers. These are important ecosystems for carbon and water storage, as well as Miombo woodlands. So we will explain the mechanisms that allow this water tower to provide water all year round. So up close, this is just using the MODIS satellite imagery for vegetation greenness throughout the year. It basically follows the ITCZ, or the Intertropical Convergence Zone, and the seasonality of Africa. You can see on the top right-hand corner. And what we did, to put it simply, was we made use of the Quito and Kubangu catchments and a cumulative rainfall along those catchments. All we did was we subdivided that to quantify where 50% of the cumulative precipitation occurs along those two basins, and then calculated the average elevation above sea level at that latitude. And we got this value that was shown in the video, 1,274 meters. And because of the rivers eating into the landscape, we've just drawn a nice, neat boundary around the water tower region. And it works really well because it encompasses all the different catchments and the headwater areas, including the source lakes and the peatland extent within the Angolan highlands, or the PA Plateau. So in terms of the buffering mechanisms, what are the mechanisms that allow for this water to flow all year round? And it's really about groundwater flow. So the water that falls as rain lands on these extensive Miombo woodlands. And then because of the Kalahari, or the underlying Kalahari sands and the woodlands, the water seeps very slowly and gets well filtered through to the groundwater level. And then when that groundwater level is exposed, or it contributes to rivers, we have peatlands that grow on the margins of rivers. And it was mentioned in the video, peatlands are very important for carbon storage and to regulate water and to clean the water. And so you have a combination of source lakes, which are the headwater systems of these rivers, Miombo woodlands, peatlands, and Kalahari sand, that allows for these rivers to flow all year round. And this is just it's got a lot on this slide, but it's really just to illustrate all the different basins that this water tower is contributing towards, and the different countries within the table. And then on the top right-hand corner, I want to point your eyes towards the seasonality of rainfall in this area. So within the Quito and the Kubangu catchments, and above and below the water tower boundary, there is a distinct dry season between May and August every single year. And so from September, that's when the rains start to end in April. We have this very distinct dry season where there's essentially no rain. But because of the mechanisms that I explained earlier, the groundwater, peatlands, Kalahari sands, the Miombo woodlands, we have this constant supply of water throughout the year. And that really leads on to the Okavango flood pulse that we were mentioning in the video. The first and second flood pulse is really just about the hydrological characteristics of those two rivers. So in terms of precipitation and the amount of flooding in the Okavango Delta, we're very lucky that a lot of different studies have been done within the Okavango Delta, and most of those studies have to do with biodiversity, but there's some that have to do with the amount of flooding. And we have 5 different papers here that are illustrated in the figure to the left-hand side, where researchers have gone and mapped and quantified how much of the Okavango Delta is inundated. And then from those estimates, we created an average inundation, depending on the amount of estimates we have per year. And on top of that, we've put in the rainfall from the Quito and the Kubangu catchments, as well as the combination of Quito and Kubangu catchments. So what you can see essentially is that a bigger flood inundation is usually as a result of more rainfall in the highlands, and a smaller flood is as a result of less rainfall, which is sometimes obvious, but it's nice to see in a graph like that that relationship is so strong. And then just to continue on the seasonality, we split the rainfall season between early rainfall. So on the on the right-hand side, we've split the rainfall season between early rainfall and late rainfall. And what we see is that the correlation between the amount of flooding and early rainfall is higher than the amount of flooding and late rainfall. So essentially, if there's good early rains within the early rainfall season, it's likely to result in a bigger flood. And if the opposite is also true. So if the rains come very late, those antecedent conditions, those conditions needed to prepare the area for a flood are not as strong, and so we won't have as big of a flood. So this is a very important quote coming out of that paper from Dr. Steve Boys. The Angolan Highlands water tower is not only keystone to the future of Southern Africa and its long-term resilience to climate change, but it has profound cultural and spiritual importance. Now that we've defined the boundaries of the Angolan Highlands water tower within academic science, we need to protect it in partnership with communities. So very important quote from Dr. Steve Boys. And so just defining the boundary was a stepping stone in the right direction, but there's more work to do. So just on future research directions, as was acknowledged in the paper by Emma Seal et al., in African contexts, we have limited data, and we have not really started to recognize water towers and given them importance. So in order to do this, we need to strengthen our data and monitoring infrastructure to allow our researchers to have long-term studies and also respond to challenges such as climate change and pollution that we're facing in African river systems. And research must go beyond the traditional defining characteristics or parameters for water towers. We have to acknowledge Africa's diverse ecosystems, increase funding, technological advancements, interdisciplinary research. I've spoken today about precipitation or climate studies and river dynamics and groundwater, and it requires all these disciplines to come together. And then also in the context of Africa, it's the continent that's predicted to become the most populated by 2050. And that will put more and more pressure onto people and natural resources. And I just want to highlight here, just say Nkonga, he was with me on the Lugubungu River expedition, and he often goes and he's done some major transects of African rivers, and he's a local from Angola. So I just wanted to highlight him there. So you can read more about this in several conservation media assets. The first one is from African Arguments, where I describe this concept of beyond snow and ice, and then several press releases about the Angolan Highlands water tower since we've published. And then we are very proud that we were able to present this data and translating research to policy. And I think this is where National Geographic does a very, very good job in enabling the scientists to present data in a creative way that's easy to digest for the layperson and even for policymakers. So on the right there, we have Jill Tiffantala, CEO of National Geographic, that met with the president of Angola, Jean Lourenço. And also on the left-hand side, this is following presentations on the Angolan Highlands water tower within Angola. And from what I've seen as a researcher, something like this does go a very long way in the context of African ecosystems. Thank you very much for your time, everyone. I think I've gone over time a little bit, but yeah, we can open up now for the Q&A.